Hi everyone. Today we're going to study random variable, probability function, and cumulative distribution function. Let's begin with a definition of random variable. A random variable, denoted by RV, is a function that assigns a real number x or capital X to every element of the sample space corresponding to the random experiment. The outcomes of random experiments may be numerical or non-numerical in nature. Most of the time, it is useful to describe the outcome of a random experiment by a number. Thus, in any experimental situation, we can assign a real number to every element of the sample space. If capital X is a random variable which can take a finite number or countable infinite number of values, capital X is called a discrete random variable. Let us now define probability function. If capital X is a discrete random variable which can take the values x sub 1, x sub 2, x sub 3, and so on, such that the probability of capital X equals small x sub I is equal to P sub I, then P sub I is called the probability function if, number 1, P sub I is greater or equal to 0 for all I. Second, the summation of P sub I equals 1. Let us define cumulative distribution function. If capital X is a random variable, discrete or continuous, then the probability P of capital X less than or equal to small x is called the cumulative distribution function or CDF of x and is denoted by capital F of capital X. For discrete random variable, the mean of a random variable mu equals the summation of capital X times the probability of capital X, which is known as expected value, denoted by capital E of capital X. The variance sigma square is given by this formula. Sigma square equals the summation of the square of small x times P of capital X minus mu square, and this is equal to the E of x square minus the square of E of x. Let us see this example. A random variable capital X has the following probability distribution. There are two rows here. The first row represents the small x, numbers from 0 up to 7. And the second row is the P of x, denoted by all these values respectively. Thus, P of 0 is 0, P of 1 is k, P of 2 is 2k, P of 3 is 2k, P of 4 is 3k, P of 5 is k squared. P of 6 is 2k squared, and P of 7 is 7k squared plus k. Now let us find number 1, the value of k. Number 2, the conditional probability of the x is greater than 1.5 but less than 4.5, given that x is greater than 2. Let us start by solving the first problem. We say that the summation of p of x equals 1. So let us add all the terms just like this and equate it into 1. The sum would be 9k plus 10k squared equals 1. Putting this equation in standard form, we have 10k squared plus 9k minus 1 equals 0. Let us solve for k by factoring. So we have 10k minus 1 times k plus 1 equals 0. For each factor, let us equate to 0. So we have 10k minus 1 equals 0 and k plus 1 equals 0. For the first equation here, let us solve for k, and the value of k equals 1 over 10. For the second equation, the k equals negative 1. But we say that k cannot be negative because this is probability. So we only accept the value of k equals 1 over 10. This value of k we will write opposite problem I. Now let us solve for the second problem. But before we do that, let us update here. Let us use the value of k. So we have now the p of 0 is 0. P of 1, which is k, now becomes 1 over 10. The p of 2 is 2k. So we have 2 times 1 over 10. And we have 2 over 10. P of 3 is the same, 2 over 10. P of 4 is 3 over 10. P of 5 is k squared, which is 1 over 100. P of 6 is 2 over 100. And P of 7 is 17 over 100. Solving for the second problem here, take note that this is a conditional probability. So this probability here can be rewritten as, in the numerator, we have p of x is greater than 1.5 but less than 4.5. And we have the intersection symbol with the x is greater than 2 all over the probability of x greater than 2. Take note that when we have the first case, the values of x will be 2, 3, and 4. While when we say x is greater than 2, we have the values 3, 4, 5, 6, and 7. The same value we will write down here for the x greater than 2. Now, in the numerator, when we take the intersection, we have x equals 3, and 4. The denominator will just be the same. Now, let us collect the values from the given table here. The P of 3 is 2 over 10, and the P of 4 is 3 over 10. And then, for the denominator, we have the P of 3, 4, 5, 6, and 7. So we're going to copy all these fractions from here up to here. And we have the fractions here now. Simplifying this now, we have the numerator to be 5 over 10, while the denominator is 7 over 10. And the final answer here is 5 over 7. This is our answer for problem number 2. So let us copy this opposite this problem here. So we are able to write the answers for problems I and double I. I hope you learned something from this video. See you again next time.